Hello, well, good to have you back. Welcome to another extension math video. Okay, you are a special breed if you're watching this. So I'll give you a joke. What type of car does an egg drive? A Volkswagen. Okay, so today we are doing integration by substitution. Okay, now it's very similar. It basically is the chain rule, but it's just a helpful tool that we have. Yeah, it's an extension of the chain rule, allows us to integrate more complex functions, especially products. Now we want to integrate by substitution. Now, sometimes they will give you the substitution, sometimes they will not. Okay, here's my hint here. Whatever's inside here, that there is going to end up becoming your substitution. So when we use a substitution, we use a u sub. So here's how we're going to do it. I want to let u equal to 1 take away x squared. Okay, now once you've done that, it makes sense that you need to find your, I guess, your du dx. Okay, so your du dx here, that means I'm differentiating u with respect to x. That's going to give me negative 2x. And so what I want to do is I want to change everything to integrate to u. So I'm going to write du equals to negative 2x dx. Okay. Now we can see that we're kind of there, but we're not quite there yet. Okay. So what we're going to do here is now we're going to replace a couple things that we do know in here. So now I'm just going to rewrite it. This is going to be the same thing as that there I can see is u to the 4, but that x there, I want to put in dx, and so it's just going to be half dx. So I'm just going to multiply it here by a half, or in this case, negative a half, because how do I get from negative 2x to just singular positive x? Well, I'll need to times it by a negative half dx, or in this case, it'll be negative half du, sorry. Right, because if I take a negative half of this, it's going to give me du and x. Okay, so that ends up becoming my equation here. And now that I've got that, I should be good to integrate as usual. So I'm going to take my negative half out front. And now I just go, okay, well, now it'll be u to the 5 over 5, right? And I actually don't have anything else to kind of go off. So it's just going to be this plus c. So it's just going to be negative 1 or negative u to the 5 over 10 plus c. And I know that u is, now I'll just replace it back in. I know it's going to be 1 minus x squared to the power of 5. And it's negative over 10 plus c. And that there's my integration. Okay, let's try another one. Again, that there is going to be my clue. So I'm going to say let u equals to 1 minus cos x. Okay, now if I go du dx, my differentiation of negative cos is negative sine. I'm pretty sure. So sine cos. Yeah. Differentiation of negative cos is positive sine. So in this case, it's just going to be sine x. Right, so that means du is going to be the same thing as sine x dx, just multiplying the dx over. So as you can see, sine x dx is your sine x. Whoops. Sine x and dx. So I can replace those with du. So in other words, I'm just going to integrate u to the power of a half because it's in a square root. And instead of writing sine x dx, I'm going to replace that with du. This is going to make our life a little bit easier. So it's going to be u to the add 1 to the power. So it's 3 on 2. Divided by the new power, 3 on 2. plus c. And just to clean it up a little bit, this becomes 2u to the 3 on 2 over 3. And again, we can replace the u with our x again. So it's just going to be 2, and then it's going to be 1 take away cos x, because that's what our u was, to the power of 3, and it's taking the square root. So I can write like that. And all that's going to be over 3 plus c. Okay. There you go. And last one. Okay. Let's take a look here. Let's go, okay, u equals to, again, what we have under here, 1 take away x. And so that means we've got your du dx is just going to equal to -1. So in other words, du equals to negative dx. Right, now what's going to be difficult here is that's 1 take away. So u is 1 take away x, but we've kind of got just a singular x here. So I'm going to rearrange this a little bit to help me out. So that means if I was to move things around, plus the x to the other side and take away the u, I can also write here that x equals to 1 take away u. Now I need that so I can replace it at the front. Hopefully you can see that. Okay, so now that I've got that, let's see what I can actually replace here. So now this is going to become the integration of an x I can write as 1 minus u. So there's my 1 minus u. And then that there is just going to be u to the power of half. And I need my, 1 minus u. Yeah, no, that's fine. And so here, sorry guys, let me write it a little bit nicer because my u's are looking a little bit like 4s. Okay, so this is 1 minus u. And if I'm writing 1 minus x, it's just going to be u to the power of a half. And then du is the same thing as negative dx. So I want to write this as du, but I'll need to take a negative out the front. Okay. So in this case here, what I'm going to end up having is it's going to be u to the half, or the integration of negative u to the half times u to the 3 on 2 du, with that negative out the front. And sorry, I shouldn't write times here. It's actually going to be minus. And so now we can just integrate both terms separately. This would be u to the 3 on 2 on the 3 on 2 with a negative out the front. And this is going to be minus u and then add 1. So that becomes 5 on 2 all over 5 on 2. And that there, we can just kind of like write this. I'm going to swap it around because of the negative at the front. Oh no, so I'll write it like this. So now I'm just going to write this as negative 2 on 3 u to the 3 on 2. And then it's going to be plus 2 on 5 u to the 5 on 2 plus c. All right, and all I'm going to do now is replace u with what I know. So I said u was 1 minus x. So it's going to be minus 2 on 3, 1 minus x to the 3 on 2, plus 2 on 5, 1 minus x to the 5 on 2, plus c. And that there would be your integration. Okay, A little bit of a lengthy process, but it's all a little bit about manipulating this section here. Okay, so you kind of work with what you're given there to see if you can almost replace everything in the integration as u's. And then once you've got everything in u, you can differentiate or integrate, sorry, with respect to u. And then once you're done, you just substitute it back to get back to your x. Just makes it a little bit simpler, use a lot more streamlined in these cases. And then so x would, yeah, be fine to sub back in later. Hopefully that's okay. Hopefully that makes sense. And I'll catch you guys in the next video. All right. Bye-bye.